What's up, people? This is Milosh. Welcome back to my channel as I take you on another exciting data visualization and GIS journey with R. This time, I will show you how you can retrieve US flights data, turn it into a network graph, and then create some beautiful network visualization with ggraph. First things first, we will install and then load the packages that we need in this R session. And we will be using to do that the pacman package. The first thing I want to do is to check if this package is already installed. So I'm actually going to do it here, and you should also put strings here. So that's the first thing. The second thing, if it's not installed, then we need to install it. And if it's installed, then it's fine. We will just be loading it into this R session. Now that we have this pacman package, we can conveniently use a function from this package, which is called p_load. So this is going to load all the packages that you already have. And if you don't have, they're also going to be installed. Now, what are the packages that we need? We need the tidyverse, which is the umbrella package. And from this one, we'll be using at least 2 for data wrangling and 1 for data visualization. Then we'll be needing here SF package because we do want to convert some of the files into the SF format. And one of them, which is US states, is already going to be in the SF format. To fetch the flights and airports, we'll be using a fantastic package, which is called anyflights, which gets us airports and flights for a specific date for US. Now, because we want to turn this into a network graph, we definitely need the iGraph package. And then to actually visualize this, we will need 2 packages. One is tidygraph, simply puts it into a tidy friendly format. That's all. And then for visualizing, we'll be using ggraph. So ggraph package or ggraph is the package that we'll be using to create actually network to visualize it on the map. Now, one last step here is to call SF package and to turn off the spherical geometry using st_use_sf so that we actually don't face any errors in the process of creating and working with SF objects. Once we loaded all the packages that we need, we can go ahead and fetch US state polygons. So there's a very convenient function from ggplot2, which is called map data. And simply here we pass states, and this is going to give us US state polygons. Now, this is not in the SF format, and I really want to work with SF. So I'm going to go ahead and actually convert this into an SF format. And in the process, I'm going to create US states SF here. So in order to create data frames like this one into an SF object, you need to use st_ss from SF package. And over here, we need to pass, of course, the data frame US states here. So the coordinate names here are long and lat, and you should actually do exactly in this order. So first longitude and then latitude column. And then you need to provide here the coordinates reference system. In our case, it's WGS 84, which we also want to change. So this is the first thing. The second thing is to convert this into an SF format, because currently what we have here, we have longitude and latitude columns, but we want to convert that into polygons. So we need to first of all aggregate by group here, where group represents each US state. So we're going to use here group by from dplyr, and then simply we're going to pass here the group column from this US states. And then once we do that, we can again call dplyr, summarize, and then for summarize, we can use this to actually combine geometry field. So we're going to create a geometry field, which is currently not there. And we're using st_combine from the SF package and simply saying here, well, simply combine geometry field. Okay, so now we will get actually the SF objects, but we also need to declare that these are polygons. So again, we will cast those into polygon. So from SF package, we use st_cast, and then simply here in uppercases, we just write that we want to cast this into polygon. And then the very last step, which I think it's optional, but it makes sense, is to convert this into an Albers projection for United States. So we'll be using st_transform from the SF package and simply here passing the coordinates reference system for it, or the shorthand, which is S3 And then here we use the colon, and then 1, 0, 2, 00, and 3. The second very important step is to, of course, get the airports. And here we can call to rescue any flights package which has information on all airports names in the US. So let's create an object called US airports and then call here any flights package that we previously installed and then loaded. And then there is a function here which is called get airports. And as simple as that, we can just call airports, all the US airports, so we don't need to do anything about it. And actually, I'm gonna here do this. And once we do that, I actually want to show you how this looks like. So what do we have here in terms of the, in terms of the columns? So I'm going to go ahead and actually write here that I want to get only a few, first few rows. And over here, what you can see is that we have the name, we have the official acronym of the airports, we have the latitude, longitude, we even have altitude and a time zone and distance and all these things. But we only care actually about 3 things here. And the first column, which is basically this acronym, the shorthand for the airport, the third column, which is latitude, and the fourth column, which is longitude. So in the next step, we will be fetching those. So we can actually work off this line here. We just simply put it into a pipe. And then over here, what we need to do is we need to use dplyr and then select. And as we said, we need column 1 and then columns 3 to 4. And this is going to fetch us the columns that we need. That's the first thing. Now, once we get these airports, that latitude and longitude that you saw, it's in WGS84, but we need that in the Albers projection for US. So what I'm going to do here is transform this data frame into an SF object, change the coordinates, and then I'm going to transform it back into a data frame. Of course, if you don't care about this part, you don't want to transform it into this projection, you can just go ahead. But I think it's a good idea because Albers projection is used when you are creating US maps. Anyways, let's go ahead here and create this SF object first. So let's work off this US airports data frame that we previously created. And then again, we do something very similar as we did before. So we convert this into an SF object. So to convert, we need to declare the coordinates names. So latitude and longitude. And if you remember, this one is called lon and lat. So without G in the name. And the second part that we need to define here is, of course, the coordinates reference system. And as I said before, it is simply WGS84. And for this one, the number is 4326. Okay, so this is the first part. And then the second part, of course, we want to, within this one, we want to make sure that we also preserve the columns. So I'm just going to write here that we don't want to remove the columns. Of course, the airports that we got also include Alaska and Hawaii, but if you saw our map, it's basically the map of contiguous US. So what I want to do here is also I want to filter out the airports in Alaska and Hawaii. And to do that, it's very easy. We're just going to intersect. But before we do that, we need to make sure that this SF object that we're now creating has the same coordinate reference system as our US state map. Currently it doesn't, so we need to use st transform from the SF package, and then simply we need for the coordinates reference system to use the same one that we used above. So we can just go ahead up here and simply copy here and paste it. So this is going to do the trick. And then finally, let's make sure that we filter out Alaskan and Hawaiian airports. So as I said, we can simply intersect using st intersection here. And then here what we need to pass is simply US state SF. This will make sure that only those airports that fall within contiguous US states will be chosen here. To create a network visualization, we of course need to have the data frame format, not the SF format. So I'm going to go ahead now and actually transform this SF object into data frame. The first thing I'm going to do here is to fetch the coordinates from the SF object. And here I'm going to be using st coordinates from the SF package, which does that for us. And here I'm just going to pass the US airports SF. That's the first thing. The second thing is to get rid, of course, of that geometry field because we don't need it anymore. And I'm putting this US airport SF object that we previously created into a pipe, and then using from the SF package the st drop geometry. All right, and once I drop that, then I need only one column from this SF object, and this is the airport acronym here. So here I can use select from the plier and simply select that first column, and then use again the pipe here. And then what I'm going to do here, I'm going to actually put together this airport acronym together with, of course, the coordinates. And to put them together, I can simply use the plier mutate. So the longitude one is going to be from the coordinates. The coordinates one that we created is actually a list. So we need the first element of this list. And then for the latitude, we need the second element of the list. So I'm here basically just copying here and pasting and changing here 1 with 2. And here is our airport's data frame with 3 columns. The first one, FAA, is simply the airport acronym, and the other 2 are the coordinates now in the Albers projection. The very last ingredient that we need for this meal is flights data, and flights data we'll be getting from the same data set using the same package, AnyFlights. Now, before we do that, we need to know for which airports we are fetching this, and luckily we can simply get information from this US airports DF. And I'm going to create an object called station, which is going to have information on that. So it's simply gonna store all the unique values from this data frame and specifically from FAA column. So that's the first thing. The second thing, we'll be loading all the US flights for a specific month. So that's a lot of data, and this requires a very stable and fast internet connection. But if you don't have one, you can increase the timeout, and here's how you do it. You call here options, and then set for the timeout the number of seconds. We can, for example, set to 600 seconds, which is going to be basically 10 minutes, right? And you can also increase this if you need, even more timeout time. Once we do that, we can finally fetch US flights. And as I said, we'll be using AnyFlights package, but this time from AnyFlights, we're using get flights, all right? And here we need to specify some arguments. So the first one is, what is the list of airports for which you're fetching this? Luckily for us, we already have them. So I'm passing here to this station. Second one is the year for which you want to do. Now, currently here it's March 2024, but I figure out you won't have the data for the last 3 months. So the latest data that is available here is for 2023 and for the month of November. So you cannot actually choose here the specific day, so it needs to be a month of the year, and that's why this is what it makes this data very big. Once you actually run this, it might take actually around a minute or even 2, depending of course on your connection, but even if it takes longer, you just need to wait a bit and just make sure that you set this timeout so your connection does not time out. Here I wanted to show you how this data set looks like, and I also wanted to show you how much time it took me to get the data. So to download 38 seconds, and then to process the flights data additional 41 seconds. And then below this one you will see I have quite a lot of columns, so 19 columns, and it's showing only the first 6 rows. We don't need all the columns here, especially those for the year, month, or day. We could also maybe filter by specific day, but that can be handled. What we actually specifically need here are only two actual columns. So 2 columns which are not even shown here, but they're here on the list, which you might see down below. So one is called origin, so this is the origin airport, and the other one is dest, which is the destination airport. Basically, this is going to be our edge list, speaking in the network terms. So this is going to be our edge list, and the airports are going to be our vertices. So edge list and vertices together will be able to create the network graph and then to also visualize it. So let's get to our next step, which is actually fetching only the distinct dyads in this origin and destination. So to get the distinct one, what we need to do here is I'm actually going to create a new object which is going to be US flights distinct. So that just make sure that I know what I'm doing. So we're going to be creating distinct flights, and of course we'll be using US flights here. I'm just going to put them here into the pipe, and then from a dplyr I will use select to only select those 2 columns that we need. So one is origin and the other one is dest, which is destination. All right. And once we have these, we can simply take only the distinct diodes here. So I'm calling here dplyr, which has a very convenient function, which is called distinct. So this is going to make sure that we have only distinct diodes. Now, there are two more steps here. As I said, so this is our edge list. We also have the airports, which are our vertices. We need to make sure that the airports in edge list match those in vertices and vice versa. So the first thing we'll do is making sure that airports in the vertices data are matching those in the edge list. So I'm creating a new object here called vertices. And then from dplyr, I'm going to be using here filter. I'm using filter because exactly I want to make sure that they match. Now, how do I make sure that they match? Well, here for vertices matching edge list, I'm actually calling US airports DF, which are our vertices, of course. And then from this one, of course, I'm going to be using FAA, which has the acronyms. For origin and dest, we have the same acronyms. So that's why it's possible now that we're going to do the matching. And then I'm going to use the in operator in base R and make sure that US flights distinct is actually origin has actually the same as this one. And then I'm going to add another condition. So and here, I want to have the same for the destination. So I'm just going to copy this one here and then change here, instead of origin, just put here dest. So this is going to make sure that vertices are matching the edge list. In other words, flights, or actually to be more specific, airports are matching flights airports. Okay, so that's the first one. Then the second one is making sure that the edge list is matching vertices. So I'm gonna not create a new object here. I'm just gonna work off the US flights distinct. And then we're gonna go through the same process here. So I'm gonna use again dplyr filter. But now within this one, we're starting off with these origin destination diodes. And then I'm making sure now that actually the origin from this one has the airports that we have from the list of vertices. So vertices and then FAA. And then another condition here, just as we did before above, is then that the dest also is having the same ones as defined in vertices and the column FAA. And we are finally ready to compute the network graph, which we will use later for visualization. And for computing, we'll be using ggraph package. So let me actually create here just a simple object G, which stands just for graph. And then I'm going to call igraph. And then from igraph, I'm going to be calling a function which is called graph from data frame. So basically, it's going to take the data frame that we have, actually two data frames. The first data frame is our edge list. So these are the distinct flights. So I'm passing here exactly that object. Then I would like this graph to be directed. So it's going to be defined here as true. And then finally, we need to also define the vertices. And this is simply our object of vertices. Once this is done, we can use tidygraph in the next step to simply course this into a tidy friendly format so that we can easily then work with ggraph and ggplot too. So I'm here using tidygraph, and then from tidygraph there is an option which is called as tbl graph, and then to this one I'm simply passing this object G that we previously created. And it's time to create our network map. In this tutorial I want to show you one of the edge bundling techniques that allows us to create actually the shortest distance from the airport of origin to the airport of destination. So in the process, getting rid of some kind of a sidelines and making things simpler. So this one is computationally cheaper, but it also introduces some bias because it does give priority to those routes that are mostly used. Anyways, let's get down to it. So we'll start off by using ggraph this time. So let's create a map object. Let's create here, let's call ggraph. And then within ggraph, of course, we'll be using the same, it's actually ggraph. So ggraph, and ggraph, and then we open this one. So we're going to pass that object gr that we previously created, and then we also need to provide here the longitude and latitude columns. So this one is lon, and one for the latitude is lat. After this, we can also add our US state layer, and this one is an SF object, so we can call geom_sf. For data here, we are using US states SF. And then here, we can actually fill it with a bit of darker color, let's say charcoal gray. And then for the colors of the US state lines, we can use, for example, white and make them somewhat thick. So let's say, for example, 0.3. And then we can, of course, do this edge bundling, as we said before. So there is a new function here. So it comes from also ggraph, ggraph again, and it's called geom edge bundle. So geom edge bundle, but there are different options here. What we're going to go for is geom edge bundle path. All right. So this one is going to make sure that we create the shortest distances from the origin to the destination airport, thus of course introducing some bias, but also accentuating those routes that are the busiest ones. Here, of course, we can choose several things. One of them is color. So here I opted for a bit of a lighter color, given that we went for a dark background, and I wanted to use actually this a light pink that you can see here. So this is what I want to use. You can also choose the width of your lines. So we can make them actually very thin, let's say 0.05, maybe 0.025 even. And in order to make them visible, we can also decrease the alpha value, so to make them more transparent. Of course, there's so many other arguments here that you can use, given that we are using, of course, this, we are using this to kind of position our routes in a specific way, so creating the shortest distance. So you can actually see here what the arguments are. There are so many arguments that you can also pass, and also explanations, but for now we're just going to stick to this one, make it like very, very simple. And then what we can do next is define the coordinates reference system that we'll be using. So we can basically just use asset package here and simply fetch the coordinates reference system, for example, for US states. And the final one is to define the theme. So I'm just gonna go and define here theme void, which just gets rid of any excess material. So once you actually run this chunk, you will finally be able to see the map of US flight routes, but organized, bundled, actually edges bundled by the shortest distance. So it actually looks like as if we're having here a road network and not a flight network. It looks very neat. Of course, it introduces some bias, so you should be careful with using this and making sure that you actually understand what you created. And that's all for today, folks. In today's tutorial, you learned how to get US flights data, turn it into a network graph, and then visualize it using ggraph. If you are interested in replicating today's analysis, I prepared a link to the GitHub repo in the description box below, so do check it out. Feel free to clone it, reuse it, modify it as you see fit. If you have any questions, comments, or just general feedback, feel free to reach out to me here on YouTube, but also on Instagram and X. If you're new to R and you seek to expand your data visualization and GIS knowledge in R, I prepared a few cool tutorials for you, so do check them out. See you next time.